Hello. Today let's talk about the Industrial Revolution, a very important period of time. What was the Industrial Revolution? Well, it was when machines were coordinated to make goods and when energy started to come from non-animal sources. Now, it's true that people had used water power for many years, but now other energy sources are really going to dominate, and we find that the world was changed dramatically because of it. There was no particular person who conceived of the Industrial Revolution. It was an evolutionary thing, and therefore it occurred over several decades. And we will treat the Industrial Revolution as an evolution in steps throughout the period. All of these steps were from creative problem solving. There were difficulties that needed to be solved for people to make more money or be more efficient or to create something that they needed to create that was not available in the marketplace. Much of the drive of the Industrial Revolution is profits. But that also was a drive that became associated with national prominence because the Industrial Revolution occurred first and foremost in Great Britain. It has changed all aspects of society. Today we live in a world that is dominated by products. Those products are the artifacts of the Industrial Revolution. I think it's interesting to take a look at the growth of technology. We've measured the growth of technology by the granting of patents. The very first patent was given to Brunelleschi back in the days of Florence at the time of the Renaissance. But here we see a graph from 1790 to into the 1900s, and it shows the tremendous recent growth of the number of patents, and the period that we're looking at is the period of the Industrial Revolution. So what we see is a shift from an agricultural society to a consumer society. All of these products are available today, and that kind of variety just simply was not available before the Industrial Revolution. Another major effect of the Industrial Revolution is a dominance of urban areas. It's because that's where factories were built, and people would flock to the factories in order to gain employment. Look, for instance, at these two maps. The map on the left shows the cities of over 100,000 in 1800, and there's a couple of dozen. The map on the right shows the cities in Europe over 100,000 in 1900, just 1 century later, and you can see that there's 2 or 3 times as many. Notice the high concentration of these cities in England and in Belgium. Belgium being one of the areas of Europe that decided to capitalize on what they saw occurring in Great Britain. Well, let's now talk about the conditions that were required for the Industrial Revolution to occur. First, there had to be raw materials, and that also includes energy sources. Second, there had to be people that could go to work. Third, you had to have a market. And fourth, you had to have capital to build the factories and buy the equipment. Fifth, you had to have a government that was willing to let the forces of the market play out. And we call that laissez-faire. Sixth, there had to be a merchant respectability. That is, people willing to go into the field of manufacturing and merchandise because it was well respected. You wouldn't want to go into it if it was a ridiculed profession. So in England, merchant profession was well respected, so people were willing to do it. There need to be innovators who are willing to, or who are able to make changes in equipment and methods that are necessary for the Industrial Revolution to occur. And finally, there needed to be a protection of the corporations that were formed in order to make the goods. If bad goods were made and the people who made them were personally responsible, then that would limit the amount of goods that could be made, because people would be absolutely, totally sure that nothing could ever go wrong. Well, that was the system of artisans. But if you're going to have mass-produced goods, you need to be able to protect the people who are employed, and that means that you need to have limited liability corporations, and that is exactly what the laws of England provided. So, looking a little more closely at England and what other factors were available in England to allow it to be the birthplace of the Industrial Revolution. England had suffered through many wars, but none of them on English soil. Next, the government favored trade, and therefore the merchant class was given a lot of government support. There was a large and very innovative middle class. England was, after all, an island, and that meant that it had to survive by trade. There was not enough arable land in England for it to grow all of the food that it needed, as well as produce the raw materials for its products. So trade was very, very important in England. The population in England became quite mobile. One of the reasons for this is that the elder son always inherited the land. That meant that younger sons had to find other places to go to make their money. Well, sometimes they'd go into the clergy and sometimes they'd go into the army, but sometimes they went into the merchant class. And therefore, that caused some respectability in the merchant class and an infusion of people. In addition to that, there was insufficient land to employ all of the people in England, and therefore the working class also became very mobile, and they are the ones who moved to the cities and went to work in the factories. In addition to that, everyone in England lived within 20 miles of a navigable river. Now that's good because you can move goods easier on water than you can on land, but it's not necessarily a solution to all the problems, because those rivers were not navigable all the year long. And therefore, later on in the Industrial Revolution, we'll see the development of a canal system to supplement those rivers. There was also a tradition in England of experimental science, that is, the use of actual experiments rather than theory to solve problems of science and, of course, also technology. Further, the guilds, that is, the associations of artisans that were very powerful in Europe, were less powerful in England, and therefore they were able to move forward without the restrictions that could be imposed by the guilds. Finally, in England, there was a very large coal supply. That meant that England had the capability of supplying its own energy. And as we will see, that becomes very important as machinery is established as the crux of the Industrial Revolution. And of course, that machinery has to be driven by energy. The Industrial Revolution started in one particular industry, and that industry is textile manufacturing. So let's go through the textile process and just think about each of the steps and the limitations of those steps and how they were overcome. First of all, the growing and harvesting of cotton. A word about cotton versus wool and flax. Cotton is actually a stronger fiber than either of the others, and therefore is easier to go through machinery. So one of the key elements was the development of long strand cotton fibers. Those long strand fibers were available principally from Egypt and from the United States, the South. And therefore, cotton became the principal staple material for the textile industry. Well, when cotton is picked, it has seeds that are stuck to the fibers, and those seeds need to be removed. As we know, that happened with Eli Whitney's invention of the cotton gin. And the cotton gin just simply took over almost immediately because there was such a demand for it. After the fibers were separated, they needed to be spun into a thread. And that was done on spinning wheels. And that was a long process. After the threads were made by spinning, then the threads were woven together into cloth. And that, of course, took place on a loom. And then finally, the cloth was given to workers who would cut it and sew it into the final article of clothing. Now let's take a look at each one of those steps, beginning with fiber separation. The problem was that if you had all of these fibers and you had a comb, it's just a little piece of wood that had little sharp spikes on it, and you would comb through, that was a long, laborious process. Well, Eli Whitney invented the cotton gin, and overnight it solved that problem. Now let's take a look at spinning and see how that problem was solved. Here's a little video that discusses how spinning was done back before the Industrial Revolution.
Hello and welcome to the Irish Farmhouse. Today here we are looking at spinning flax into linen thread. When we are doing our spinning, there are 3 steps to this process. The first step to spinning is to draft or pull the fiber down off of the distaff. The distaff is the wooden stick that you see on your left. If you watch Joan's hands carefully, she's pulling fiber down. She's either thinning it out or making it thicker, depending on the size of the thread that she wants to spin. The second step to spinning is to use your foot to press down the treadle or pedal at the base of the spinning wheel. This constant movement keeps the wheel spinning at a regular tempo and will put twist into the thread that you're now making. The third step to spinning is to dip your fingers in water. The water is rubbed over the thread to cause the fibers to stick together. This will make us a stronger, smoother linen thread. We can then use our thread for weaving or for sewing linen fabric. Here's our finished product. On the spinning wheel, you see the thread that we've just made, and to your left, a ball of thread that we have just removed from the spinning wheel. This is what we'll use for making our linen fabric. Keep in mind that children would be learning how to spin when they were about 5 or 6 years old. This concludes our spinning lesson. Have a good day.
It took about 4 or 5 spinners to make enough thread to supply one weaver. Therefore, spinners was a pinch point, if you like, in the entire process. The way that spinning would overcome that problem is you just had lots and lots of spinners. So any person who could not find a good job could always make a little money as a spinner. It's important for women who are unmarried because they have no other ready source of income, or for women who may be widows. But that unmarried woman, of course, was known as a spinster for this very reason. It was the common way for a woman to make money if she had no other way. Well, the creative solution was simply to put together many spinning wheels into a single machine. That was done by a man who invented what is called the spinning jenny. He was walking through an area one time and he saw a spinning wheel and it had been knocked over on its side, and he saw it still spinning, and somehow that gave him the idea of joining many spinning wheels together into a single machine, and he was able to join 15 or 20 spinning wheels together into what he called a spinning jenny, named after his daughter. And therefore, spinning went from the output of 4 or 5 spinners for one weaver to exactly the reverse. Spinning became much more productive than weaving, and therefore the next pinch point in the textile process was weaving. Let's see how that problem was solved. The difficulty in weaving was that as you weave, the threads are in the long direction and they are in 2 racks, or maybe even more than 2. And as you weave, the racks are apart and you put a cross thread, and then the racks change positions and you put the thread back the other way. You tap it in. And then they change positions again and back and forth. So weaving is a process of changing the positions of the fibers in the long direction and then throwing the shuttle, it's called, with the threads in the cross direction. And when you do that, quickly, you can weave quickly. But it was difficult to throw that shuttle back and forth all the time. And therefore, the solution was what we call the flying shuttle. Now, there was a further difficulty, and that is that people may want to have a pattern in their cloth. So here we see a video of a woman who is creating a pattern. And she does that by selectively lifting some, but not all, of the threads in the long direction and putting a cross thread underneath them.
खुट्टाले चाहिँ अब जस्तै यो क्रस गरेपछि
हजुर
अब क्रस नगर्दा चाहिँ अब यतिकै सादा मात्रै ठोकिने भयो हैन
हजुर हजुर
अब क्रस गर्दा चाहिँ यसको यो बुट्टाहरु जस्तै यो
हजुर
यो क्रस बिना यो हुन्न बुट्टाहरु
हजुर
हैन क्रसको अर्थ चाहिँ यो बुट्टाहरु तयारी गर्ने.
So this is a process to create patterns by selectively lifting. Well, how could you solve that problem? That was solved by the process that we called a jacquard loom. And a jacquard loom, we will see, had a way in which the fibers were lifted by penetrating a card. And that card had holes in it, and that allowed the lift of certain threads. Now, here was a problem. You had to gather the thread from the spinners' homes, transport that thread to the weavers, gather the cloth from the weavers' home, transport that to the sewers' homes to make clothes. That took a lot of time and a lot of transportation, and so that problem was solved by putting all of it together in a single factory. The man who did that was named Richard Arkwright, and here we see the facade of Arkwright's factory that was built in 1769. This factory had each of those steps. Let's take a look at them. Here I'm in the room where we do the weaving, and I describe that process.
We are now in one of the weaving rooms, and as you can see, these are driven by a central belt system. Overhead, we see a series of turning spindles to which belts are attached. Those belts then drop down, and they run each of the machines. The machines themselves are not running. If we look towards the back, you can see the machine running, and in fact, you can see the spindles going back and forth to control the thread going to the weaver. This is a very typical area again for weaving cloth.
Next, I go to a room that has jacquard looms so that we can see patterns being developed. Take a look.
This is a more complicated weaving system. As you can see, there's overhead threads that are being drawn in to give more complicated pattern. And this system depends upon what was called the Jacquard card system. Here we can see one of those cards. It's like a player piano or an IBM punch card, that wherever there was a hole, a rod would go through and that would lift one of the threads. And so you could see that you can develop a pattern by varying the holes, and that would give a very complicated weave. As a result, the cloth that is made on this system can be more complicated and have a more intricate design than cloth made on a standard weaving.
Here is the outside of the factory so that you can see the water power from which they got the power to run all of those machines.
This is behind the mill, and obviously it's out on the river. This is the power source for the mill. And the mill was built here in the Peaks district of central England because they have hills with fast falling water. And behind us we see the little dam, and that dam creates some lift in the water. Then off to the side is what we call the mill race, where the water at the higher level is diverted and comes into the mill area. This is the mill race, and the mill race comes down, and it's, I would say 30 feet higher than the river at this point, so that it has some potential energy to it. And then this higher water moves into the plant itself.
Here's a video showing the turning of that water wheel and the linkage to a wheel that drives the entire factory. Here was a problem in those factories. The water power was limited only to steeply falling rivers because they needed enough energy gained from the potential energy of the water to drive the factories. They had to think of some other way to get energy because there just weren't enough streams to do that. Here in the Arkwright factory, they quickly ran out of enough water power. They needed to do something else. And so what they did is they went to steam power. Here in the Arkwright factory, we see steam being put in to replace the water. Steam is more reliable and therefore, and also can give greater energy and therefore is preferred.
After many years, this plant was converted from water power to steam power. And this is where the steam was generated in these large boilers. They then went into a steam system that drove pistons. But here you can see a very large boiler system that is then upgraded over here. And in fact, because this is a plant that is still working, we have two new boilers that are very recent, and they now run the plant instead of the old one.
Yes, this factory is important. Here's a little summation video that talks about the entire factory.
We're now outside the Arkwright mill. As you can see, the old mill that we've just been through is this lower part. And then a new mill expanded over several generations, has been built. It has a large smokestack that is indicative of the steam system that we have just seen. And then, if you move to the right, you see a mill that has been converted over into a series of shops. Quite lovely woolen goods and cotton goods are for sale there. And it's quite large, one of the largest mills in this area. It's still a working mill. The lower portion is where we've been. It's the old mill, and then the new one is built up around the outside.
Well, now let's focus on power, because that has become, in the Industrial Revolution, an ever-increasing problem. Originally, as we went into the Industrial Revolution, people used animal power. Here's a typical example of a cow or an oxen used to drive a wheel. Problem, of course, is there weren't enough animals. The next was water power, and the problem is you don't have enough steep rivers. So the creative solution to that was to go to coal with steam power. And here's a coal mine in Wales, and it was a place where they dug the coal to supply the steam. Now, there is another problem, another situation. The iron industry is expanding to make the machines used in the factories, but they don't have enough iron to make the machines. Therefore, what can they do? The wood supply is gone, and so they start to use coal, not only to create power, but they use the coal to help with the iron as well. There was another problem, and that is in the bottom of the coal mines, it was wet because the water table is often very high in England. And so what could they do to get the water out of the mines? And that solution was to use the water pumps. Well, you can't use animal or water power to pump the water out, and so a new solution came about, and that was a steam engine. Here is the earliest model of the steam engine. It's called a Newcomen engine, and it was reasonably successful, especially as a pump for pumping the water out of the mine. But a Scotsman named Watt saw that the poor efficiency from this type of pump could be improved if you separated the area where the steam expands from the area where the steam is compressed. And by doing that, it means that the hot area could always stay hot and the cold area always stay cold, and that dramatically improved the efficiency. So Watt was not the inventor of the steam engine, but he was the inventor of an improved steam engine. Now, there arose another problem, and that is the goods needed to be transported, but the navigable rivers were not deep enough during the dry season to do that, and so the solution became canals, and England was crisscrossed by a canal system that really made things work, but there were even some parts of England where canals didn't work very well, so you had to have something else. Well, now what are the people going to do? Oh, well, the solution there is the railroad. So what they did is they took a steam engine and they put it on a carriage and wedded the power of the engine to the wheels, and they got railroads. Here is one of the early railroads, in fact, one of the very earliest of all, and you can see it is just literally a steam engine mounted on a carriage. Well, if you're going to build transportation system with railroads, you've got some problems. You've got valleys to cross with very heavy equipment. How are you going to do that? Oh, well, you better make some bridges, and they better be very strong. And so iron bridges were invented. Here is the very first iron bridge. It's called Iron Bridge, and it is a beautiful thing, very strong, still used today. I've walked across this bridge myself. Now, let's see the effect of industrial of the Industrial Revolution in the various countries of Europe. This is a chart that shows the per capita industrialization in each of the major countries of the world. Great Britain was taken to be the standard, and the standard was assigned at the year 1900 as 100. So you see the growth from 1750 to 1900 in Great Britain, and it's a very steady growth all the way up to 100. Belgium, which is a new country that decided that they were going to use industrialization as their focus, did a reasonable progression as well. The United States, where industrialization was quickly realized as an important part of our economy, also made a strong growth through this period. France, reasonable growth. Germany, a very strong growth. Austria, reasonable. Italy, less. Russia, less. China, almost no growth. And India actually went backwards. The reason it went backwards is because India became a raw material supplier and not a manufacturer. Now, I want to call your attention to 1913. Notice that Great Britain has grown to 115. Belgium has accelerated tremendously to 88, but now the United States has jumped to 126. It has become the most industrialized country in the world. We'll talk about that when we discuss creativity in America in the 19th century. France has maintained some manufacturing, but it is certainly not as strong as, say, Germany. Austria, Italy, and Russia are just simply moderate in theirs, and China and India have yet to catch up. England began to stagnate. One of the reasons that it stagnated is because England believed that because of India and its other colonies, it could get cheap raw materials in, and then it could take its finished goods and sell them under preferential treaties to its colonies. Therefore, English manufacturing didn't have to compete with the rest of the world when it sold to its own colonies. But eventually, that resulted in English manufacturing becoming less competitive and less efficient. The United States and Germany, they had very few colonies, and so they had to compete with everybody else in the world on a one-to-one basis. That made England less competitive than the aggressive American and German manufacturers. As a result, England eventually began to stagnate and fall behind. And the problem was exacerbated as England lost their colonies in the 1900s. Let's just talk for a moment about the conditions that arose because of the Industrial Revolution. People flocked to the cities, and in the cities, they were housed in makeshift, quickly erected, terrible condition apartments. The people suffered greatly in these cities because of very long working days and very bad living conditions. They also suffered because of working conditions that were terrible. Very few safety rules were enacted, and young children were often used in the manufacturing environments, sometimes preferentially because they could get into places because they were smaller and they could do things that adults could not do. Stories are told, in fact, testimony is given of young children who are wakened at 4 in the morning so that they could leave their home and walk to work, where they would arrive at 5 or 5:30, and they would work a 12-hour day. It was just unheard of drudgery for these poor people. During this period, there were some who hated the technology of industrialization. One group was known as the Luddites. They were artisans who felt like industrialization was going to take their jobs. And to some extent it did, because the Luddites didn't realize that artisanship could create goods of luxury that mass production was probably unwilling or unable to produce. Nevertheless, the Luddites did not see that advantage that they would have, and they decided that they would try and stop industrialization. They would go to a factory and cast objects into the machines. In fact, it's said that the word saboteur comes from people like Luddites casting wooden shoes into the machines. But the Luddites were unable to stop the problem that they saw as a problem, unable to stop technology. In fact, you might ask yourself, is it possible to stop technology? And I believe the answer is no. The reason is that technology provides things that people want, and therefore there's a tremendous incentive for technology to succeed. Now, does that mean that technology is always without problems? And the answer is, of course not. But we have to think of technology in terms of time. Short time, technology solves a problem, and therefore it has advantages and is quickly adopted. Medium term, we start to see the problems with that technology, and therefore that technology is either slowed down by some or the problems are solved by others. But in the long term, the problems are going to be solved. People are just very, very clever, and they will figure out how to solve those problems, and therefore technology, in my opinion at least, will eventually triumph. So how do we control technology without stifling progress? First, we must take the long view, realize that technology advance is inevitable. Secondly, we have to take a broad view. We can't just focus on technology. For instance, if we were in the textile industry, we wouldn't just focus on textiles, we would also focus on the building of factories and housing and all of the urban support that has to be created in order to make the factories succeed, because you want to provide something good for the people. Now, in the Industrial Revolution, people started to do that, and there were factory towns that were built to provide all of the amenities that were needed for the people who worked in the factories. Some were tremendous successes, and some were dismal failures, in part because in the failures, the factories were seen as a way to exploit the people, and in the successes, the factory towns were seen as a way to enhance and support the people. That brings up the next issue, and that is ethics. There has to be an understanding of the ethics associated with technology. And if we understand that and apply it properly with a broad view, then we believe that that will allow technology to succeed. And all of those require creativity, because they are solutions to problems that are new and therefore unique. You might ask yourself, do you love or hate technology? I know I've said bad words at my computer every once in a while, probably because I have some residual fear of technology, but in general, I love it. You might also ask, is complexity good? Because certainly the world is becoming ever more complex. Some people are turned off by complexity. They just hate it. But what we need to do is find a way to simplify our lives through the use of technology, so that technology and complexity are not necessarily linked together at the human level. Well, sometimes complexity can be so difficult that it itself becomes a problem. Look at what was said here by Robert Poole. Complexity creates unpredictability. The more complex a system, the more difficult it is to understand all the different ways the system may behave, and in particular, to anticipate all the different ways it may fail. Interdependence among parts creates entirely new ways that things can go wrong, ways that engineers often overlook and ignore. The challenge is, therefore, on engineers and technologists that they think deeply, broadly, ethically, and creatively. Thank you very much.